We have seen in the last video that in order to serve a request, in general, we need to do three things. We need to have a database connection, we need to look up the session from the cookie, and lastly, we need to check if a user is logged in on the basis of the content of the session. If these three things are done, so after they are done, we can process the actual request. So we want to look at how to do these three steps that we will have to do pretty much before every request. So we do it in this way. This is a controller. It's in the file controllers.py of a new app I created. I called it fixture example, but it is simply a clone of my Bulma scaffold application that you can find on Bitbucket. So I want to focus on these two lines that precede the declaration of the index Python function. These two lines have the following purpose. So at action with the index as a string in it, this means essentially that the URL will be accessible from localhost, etc., but then there will gonna be fixtures example, okay, so the name of the application, and then index, which is, so this string here is essentially the same string here. So essentially this is used to declare at which endpoint, at which URL you make this function available, okay? The other line, this action.uses, is what it is used to perform the steps 1, 2, 3 above. So we put in it a DB object, an authentication object, and actually also the template we use to enter the page. And I can tell you now, and I will explain you in detail later, that it would be okay actually to put here also the session object. I do not need to do it, and I will tell you later why, but perhaps this would be more readable with it, as you would then see really steps 1, 2, and 3. But let me leave it as it originally is. And I want to talk about how to create these objects and also how they behave once they're put in this action uses line. So let me use actually PyCharm to chase the definitions around, and if I look at the definition of DB, you see that I imported from common. Common is usually the place where you put all these declarations of objects that you're going to use throughout your controllers. So let's look in there and see what it tells me. This is how I created a database object. So a database object essentially represents a database inside Py4Web, and is an object that has methods that enable me to do queries against the database and store results back to it. So this is created by passing DAL. DAL is the database abstraction layer, and I need to pass to it various things. One is the database URI. This is essentially an indication of both what the type of the database is and also the location of the database in terms of how to connect to it via the network. Okay, this folder is used in case I use a local folder. You know, the database that we are going to use for development will have a database URI that will simply say SQLite, and the folder would simply be this database folder, where in the end these files end up for the database, because it's a local experimentation database. There is a pool size, you don't need to worry about it in general. There is a migrate setting that essentially means if migrate is enabled, so if this migrate is set to the default value, which is true, then Py4Web constantly checks whenever you restart it that the database tables correspond to your declarations, and if they do not, they will be adapted to correspond to the declarations. We will have occasion to talk about this later when we do the lectures about databases, okay? These settings for the database are in the settings file. We can go examine it in detail. And here they are. These are the settings to connect to a database. You can see that we're using an SQLite database for testing. The pool size is 1, migrate is true, and fake migrate is false. If you want more information about how to connect to a database, the place to look for that is the Py4Web documentation. If you go into the chapter for the database abstraction layer, DAL, you can find, for instance, all the connection strings that tell you how to specify to which database you want to connect. For example, if you want to connect to a MySQL database, you use MySQL : / username : password, @ localhost, etc., etc. So you have precise instructions, and you can see that there is a large number of databases that you can use and interface to. This is one of the beauties of Py4Web, that you have this uniform way of interfacing to many different databases. Okay, so this is how you create the database object. Once you have it, that will give you access to the database. And another interesting feature of Py4Web, by the way, is that you can have multiple database objects that connect to different databases. It's not very common that this is useful, but if you want to do it, you can perfectly well do it. For instance, if you want to design an app that migrates data or moves data between two databases, that's quite easy to do. Okay, so this is how we created the database object. On the basis of the database object here, we also created a session object. The declaration is here in the commons.py, is a bit below. It's here. Okay, pick the session type that suits you best. So you need to decide where you want to store the session, and I want to discuss it a moment. I can tell you already though that in this class we will always store the session in the database, which in my opinion is the best choice, but I want to tell you what the other settings mean. So to remind you, we want to be able to read the user cookie and from it recover the user session. The typical case is the one in which the cookie contains a long random string, and to recover the session, then we look up the string in the database and we read the session out. Okay, so but you have various choices for the session type. One idea is to keep the session simply stored in the cookie itself, so that instead of using the cookie to look up the session, the cookie itself contains the session encrypted. You encrypt it so that the user cannot tamper with it. Okay, you encrypt and sign it. This is done automatically by Py4Web for you. So what are the advantages and the drawbacks? The advantage of keeping the session in the cookie is that you avoid a database lookup. This saves you a little bit of time. The cookie, you have it already, you don't need to look up the string in the database, you just need to decrypt the cookie. The drawback, however, is that cookies, being meant to be sent with every web request, have a size limitation to prevent people from, creating very bloated cookies that then would slow down browsing. So the size limitation is of 4 kilobytes. Now, if you think at what you want to put in the session, very frequently you will conclude that 4 kilobytes are more than enough for you, and they will suffice. The problem is that when you do more and more web development, there are more and more pieces of your environment that can introduce data into the session. Let me give you some examples and we will see them better during the class. But for example, when you generate a form, and the form will need some validation, and the information to validate forms will be stored automatically without you needing to be aware of it in the session. Similarly, when you sign URLs, there will be a signing key, whatever it is. I will tell you later what it means to sign URLs. But it is something that you will do it often and you will do it automatically. There will be yet another signing key that goes into the session. And so when you do this and that, there can be more and more pieces of information that are added to the session without you perhaps having full realization of it. And my experience has been in the past that the session tends to get bloated. And the problem is that if you ever go over the limit of the cookie size, what happens is that the cookie is not transmitted. So in practice, the user is automatically logged out. Okay, keep into account that the 4K limit is for the encoded cookie. The raw cookie, the raw information that you want to write into it is smaller, may only be perhaps 2 kilobytes or so, right? It depends on exactly what you're going to write. So imagine that you develop a website and your user is there, perhaps looking up some very complicated flight or trip, which involves a couple of flights and a hotel and has put everything in the shopping cart. Or imagine that the user is there on a shopping site and has carefully selected 3 or 4 products already in the shopping cart, etc., etc. The user is there engaged with your site. And being engaged, it has navigated it at length, and more things have perhaps had time to accumulate in the session, and then all of a sudden you go over the session limit and you log the user out. I mean, that user is going to be annoyed, right? Because all the session is lost. Nothing is left in the shopping cart. It's worse than being logged out in a sense, because the whole session is lost. So even the content of the cart is lost if the user was not logged in. So you can't store the session in the cookie if you like. I do not particularly recommend it, but you can. Redis and Memcache are 2 memory cache services that you can use. And the idea is that the access time hopefully is going to be smaller than the database one. Okay, so you can do that. The drawback is again that these services typically do not guarantee that they hold the information forever. And so again, you run the risk of logging out users randomly. So I don't particularly love them. Okay. The last choice is what we will be doing. We store the session in a database, and we do as follows. We create the session object. I will go now to look at how the session object is created. But okay, we give it an encryption key somehow. You can modify it in settings, and perhaps you should. I don't know what the default is. Yes, it's not a very good default. You can when you go put your site in production, we can replace these with a UUID or with your own secret passphrase somehow. Okay, so you give it a key for signing, and then you give it a DB store that is built out of on top of the database. Essentially, the database gives you the ability to store the session, and this DB store is an object that only has 2 methods, one to read the session out and the other one to store it back. So if you want to use your own crazy type of database, you could build a DB store object around your own crazy type of database if you didn't like the DB object for some reason. We can look at this implementation. It's actually quite short. And so this is it. This is the DB store object. As you can see, it has 2 methods, get and set. The get method, you give it a key and it will read out the session. You can read the code for yourself, right? I just want to show you the general lines of it. And the set method, you give it a key and a value. The value is the session and an expiry time, and this will write it. Okay, so it's quite simple code in the end. Okay. So, and on the basis of it, you create a session object. Okay, so in practice, we will leave our session type to be database for us. I mean, that's my personal preference. It's cookies. Database. Okay, and we will have it in the database. Yes, I should fix the default type. I will fix it. The third object we create is an authentication object that will manage the login, logout, registration, and etc. for users. This is one of the great things about Py4Web, that we have this object. It will make it much easier to build our own sites. So we need to do, in practice you have this boilerplate code that is almost always the same. And so the code from here to the end of the screen basically defines the auth object in the right way. You need to pass it a session because it needs to store, the user identity in the session. You need to pass it a database in which it will store the user table. There is a page, there is a table containing the username, user email, encrypted password, etc. And So this defines the auth object, and then you can set a lot of methods to it. So it has a lot of parameters. You can customize the parameters, and they've done a bit of customization for you. You can change it. Okay, you can customize the classes so that it shows up these forms in which users register, log in and log out, have the right classes and render properly inside Bulma. This is slightly different from the standard that you can find in the Scaffold app, precisely because I adapted this code in order to work better with Bulma. Okay. You can decide whether users log in via username or email. I typically prefer people to log in via their email directly. And you have a lot of other things that you can set. For example, do you want registration to require confirmation? If you say yes, you have to have a means of sending email, and an email is sent to the owner of the account, or an email or an SMS if you connect with Twilio, for instance. And at that point, they need to click on the email to confirm that they own the email account before they can log in. Registration requires approval. If you set this to true, then you will have to manually go in. You will have to probably write a method for a web page in which the admin can go in and approve every new member. Okay, so if you want to have that option, you turn this to true instead of false. There is a login expiration time, which is 1 hour. I don't quite know why we want that to be so short. I think I may increase it. Then there is this is important. There is a password complexity parameter. I put it equal to 2 because I want it low for development purposes. You know, my development passwords are incredibly simple. Both to avoid any similarity with my real passwords and because they're easier to type. So I moved this down to 2, but you want a better number, like 50, for production, so that you essentially force people to choose a complex password when they create their own account. You can block previous passwords. This says that I want the form style to be Bulma compatible, and here I define inside the database the tables. You see, I had set it to false initially, but now that I have fully configured the auth object, I actually want to create the database tables to hold the user information. Okay. So this is how you created the 3 objects, and the question now is, once I have created them, what do they do inside here? No? So what is the point of having them here? What does this action uses does? So this action uses essentially causes these methods to be called at the beginning and at the end of every web request. So let us look at the database object, for instance. Well, okay, it's declared here. Let me look at the declaration of this DAL object, which is the database data interface abstraction layer. So if I look at it, this is what it is. It is a very simple class that inherits both from the database abstraction layer of PyDAL. PyDAL is the package whose documentation you have seen here, right? PyDAL is the package that gives us the database abstraction layer. And we also inherit from a fixture, which I want to show you next. Essentially, fixtures have things that have these methods. Actually, let me show you immediately what a fixture is. This is a fixture. So something that appears here, like database, auth, etc., are fixtures. And a fixture has these methods. There is the onRequest method that is called when you do perform a web request. There is an onSuccess method that is called when the processing of the request has terminated. And then there is a transform method that is also called when the request has terminated in order to transform the output. You can momentarily disregard this transform method. It is used essentially to implement the templates. Okay, so the most important for you are on request, which is at the beginning, on error, which is if an error is raised, and on success, which means if you have processed the request correctly. Okay, so anything that implements fixture needs to implement these 4 methods. So let us see what a database does to implement those. Okay, when a request is initiated, the onRequest method does, if self reconnect on request, it asks the database to reconnect. This underscore adapter is the adapter of the database. Okay, and then it will mark something in this, it will essentially load a thread safe variable for the internal variables of DAL. You can, disregard these. If there is an error, it will roll back the transaction. It means it will undo as far as it can the effect of the transaction on the database, unless you have already committed a portion of it. And on success, it commits your transaction. We will see later what this means, but let me tell you in a vague way. I told you previously that databases manage consistency. So when you start talking to the database listens to you and says basically, but it doesn't actually do anything. It takes note of what you want to do. Then if you do a commit, your transaction and your changes are actually written out to the database at that point. And if you don't do a commit, but you do a rollback, then your changes do not take place. This is a kind of a quick explanation, but it's mostly correct. Okay, so the DAL is the database object, you put it into the fixtures essentially so that at the beginning of a request it makes sure via this line that you are connected to the database, and that on success you commit the changes to the database so that they are written out. The session object is also a fixture. And it's quite interesting to read, actually. So let me go look at it on your behalf, right? So that I can explain what is in it. So the session object is created here. You see, I'll use PyCharm to navigate around the code. It's very convenient. You see, a session implements fixture. So a section has, you can read the rest of the code, but I want to focus on the implementation of the methods on request and on success. So let me look at these are here. So on request, what you do is that you load the session. On success, if the session has changed, you will save your session. How is this load and save performed? Let's look at it a moment. This is the load code for the session. And you can, I like the term, you can read it in diagonal, meaning that you don't need to make sense of every tiny detail, but it's good to have a general idea of what goes on. When you load the session, you first read the token from the cookie, or else you read it from an attribute of the request that was passed to you. But in some way you get the raw token. You convert it to bytes, etc. And then there are basically 2 big cases. If you're using storage for storing the session, so if the session is not directly in the cookie, what you do is that you say self-storage get the token data. Okay, so use please the token to look up the session. And you get this data in JSON that you decode. Instead, if you are not using storage, if the session is directly stored in the cookie, what you do is that you decode the cookie content. This JWT is the JSON Web Token implementation. So JSON Web Tokens are a way to encode and sign some content, essentially sign some content, okay? And so this will decode the session for you, okay? By the way, I forgot to mention, another important reason why I don't like to put the session in the cookie is that you want to feel free to put in the session things that the user ought not to know. For example, suppose you want to denote a user with the fact that they are a nuisance, that they have already returned the 16 items to your store and you would rather not deal with them anymore. I'm making a joke, right? But it could be that, right? Then you may have, this flag like nuisance is equal to true in your session to remember that this user, can be a pain to deal with. You probably do not want the user to see that as part of the cookie. Now, few users take the time to decode their cookies and look into them, but I think it's generally a better habit not to give users information about their own sessions. Okay. So I say essentially you have two cases. In one case, you get the session information by looking up the token, and in the other case you decode the token. But at the end of it, you have the session information. Okay, you can read the details later. Now, when you save the session, it's in some way even more interesting. So there is an if-else here that again corresponds to the two cases in which you either have to set the cookie set the updated session in the storage engine, or encode a new cookie. Okay, so these are the two cases. But then essentially you set a cookie, which this piece of code is also used to set the cookie for the very first time. Okay, and so this set cookie operation can be used to create cookies. You can also call it yourself if you want to set additional cookies. A cookie has a cookie name. We can look at how it is defined, the cookie name. So browsers can have multiple cookies for the same site. Cookies are distinguished by name, and we will see these. You can see these. So for example, I don't know, google.com, I can have a session cookie, I can have an advertisement cookie, I can have an email cookie, whatever. Now, I don't know how many cookies Google uses, more than one generally. And so this cookie name is generated here. It's useful to look at it. This is a cookie name. You see it's generated by saying session with also the app name. So if I aim in an app as I am now that is called fixture example, the name of my cookie will be fixture example _ session. So if you serve multiple apps from the same Py4 web server, like there is fixture examples, lecture HTML, my feed, soccer, to do, every one of these apps will have their own cookie, and you can be individually logged into any one of these apps. Okay, this is very clever and nice, because it enables you to use a single Py4 web engine to serve multiple applications. So the other important things to look at, so coming back to how the cookie is set, so it has a name, it has a content, okay, which is the cookie data. It has a path, that means root path is always sent for this particular site. Secure means whether the protocol was HTTP or HTTPS. And same site is a very important characteristics to which I will come later. Essentially, to give you a super brief summary, it's a new standard on the web. Traditionally, every request to a site carried all the cookies for that site. This opens various possible security attacks if one is not careful. And so the idea was introduced that cookies should only be sent back to the site where the page originated. And so I want to cover this in detail in another time. We will have a special lecture on security. But I just want to say that this setting of same site to the default is lax, even though it doesn't sound very good. It's actually what it will enable us to have additional security in Py4 web. Okay, so again, there are many open threads of things that I will have to cover another time, but you should look at these methods load and save, because they are one of the really core pieces of Py4 web and of how the framework works. Right, this is what enables you to recover the user information and to store it back at the end of a call. Okay, So the last object that I should comment about, but I will not do very much actually, because it's a bit more complicated, is this auth object. It's also a fixture, you can also look at it. So you see it is also an extension of fixture. We can look at it super briefly. It can define its own database tables. You see here the code. It can sign things. It has a user method, a get user method to get user information. It can tell you whether the user is logged in. It tells you who the current user is. These are all methods we will use in development. And these are methods for allowing registration, for allowing login. You can read the code if you like. And the methods I'm looking for are sorry, I need to scroll a bit down. Hey, where are they? These on request. They must be somewhere. On request. Here it is. So on request, we check that we have a user in the session and the condition is met. So we take we look first in the session. Do we have a user in the session? And if not, we do something. Okay, this is on the request. This is the on request method. Okay. Essentially, the idea is that when you log in, the user properties are stored in the session. And in the onRequest method, you are going to read that information from the session and restore the user information. That is what goes on. So to pop out from this level of detail in which we examine these objects, we have these DB and auth and session object. Now, the question you may have in your mind is, that's great, but what do they do over here? And what does this action users does? So these action users, you can actually read the definition of that as well. It's actually not a lot of code, but it's perhaps not incredibly trivial code. So I can tell you by voice what it does. This action users essentially finds all the fixtures, including the dependencies, and it sorts them in a dependency order. Let me show you what the dependency order is. If you look to the database is defined in this DAL object and it has no prerequisites. But if you look into the session object, okay, which is created here, if you look at it, you will see this funny line that says, hey, if you want me to use storage, then I need to have in my prerequisites storage. If you look here, the storage is this DB store, and this DB store depends on the database. So essentially, if we were to draw a graph, we have that the database depends on nothing, the session depends on the database, and the auth object, if you read its declaration at the top of this file, you will see that the auth object depends on, it's here, it depends on the session and on the database. So there are these prerequisites for each fixture that say what do you need to have before. And so when I cite these controllers here, I just cite DB and auth, and this essentially implies also session, because auth depends on session. That is why writing here session is optional, but is not required. And this three elements both get to act before I can process the page. So the short of it is that if I run this code, which I will do now, I will have a connection to the database, I will have auth active, and I will have also, a template for rendering. So this page, all it does is that it tells me who the user is. And I have this getUserEmail method that tells me the name of the user. If you look at how it is implemented, okay, it takes the auth object and it takes the current user from the auth object and it gets the email out of it. If you have a current user, and otherwise it says none. Okay, so getUserEmail gives me either none or the email of the current logged in user. So let's see how this all works. So let me start Py4Web. Okay, I need to check that there are no errors, and there is an error. But this error happens frequently. It simply says that the address is already in use. I have apparently another instance of Py4Web running. If this ever happens to you, you can either kill the other instance, or you can change here. If you go look at edit configurations, okay, here you could specify a different port from which to run Py4Web. Okay, I killed the other instance of Py4Web running. Now I can connect it to my usual port. So I can copy this URL. I can go to my browser. I can copy the URL here. And if I do this, I end up on the dashboard. But I want to go to, see, this application is called Fixtures Example, and I just defined the index method. So I should use these as the rest of the URL. So let me do that. And this simply says hello. And it doesn't say anything else, simply because you see, the user none. Simply because, I'm not logged in. So let me try to log in. Okay, and notice that I have changed the session to be in the database. And so if I log in, this should work. Let me sign up actually. I always use the same password for development. Okay, so I should be able to sign up. I don't know why this does this instead of because I have signed up and not logged in. A bit noisy, nasty. But you see, now this tells me the username here once I log in. There should be a setting for registering means logging in. I don't know why it doesn't do that. But so here it gives you my email. This is done via the layout. So the layout is already done in such a way that you have this interaction working. I set this up into the scaffold Bulma. And here, now it prints that the user is luca@deafaro.com, which is my email that I used for registering. Now you may be underwhelmed that when I go to the web page, it simply says hello. So I can easily fix it to say hello, my username, right? So in fact, suppose I want to have the case of hello, hello unknown if I'm not logged in, and hello, username if I'm logged in. Okay, so how do I do that? Well, I can say here hello. I can return a dictionary for the template that says, for example, email is equal to get user email. Okay, and then I have to say first name is equal to, let me look at how I did this lookup of the user email. Okay, it's here. Let me copy this line a moment. So auth current user get, the field is called first name, else none. Yeah, that's fine. And then I can say last name is equal to, and I use a similar line in which what I get is the last name. Okay, so now I will have this information available for the template, and in the template I want to do something that is actually common. So here I go into my template. You see now it just says hello, but I wanted to have two cases. This is what is common. Okay, so I want to say how do I figure out if a person is logged in or not? Well, look at the information I give. This get user email will be either none or will be a user email, right? So I might as well use that simply. So I can say if user email, did I call it this way? I'm sorry, email simply. If email, okay, and then I will have an else block, okay, and then I will have a pass. Sorry, pass. So I can even add HTML comments. Okay, I can say, for example, the user is logged in. Okay, and then I can say the user is not logged in. Okay, so these are the cases. This is a very common way to organize the home page, right? You typically want to show fairly different content if one is logged in or not. So you can say here welcome, comma, and first, so equals, I have to read the value out of the Python variable, first name, last name. And here instead, below we can write something like welcome or you passerby. We hope that you will consider registering. Fat chance, but we can always hope, right? So, and if I make this change, now I want to restart Python Web because I have changed also the Python, so I need to restart it. If you run it from the dashboard, Python Web knows how to reload itself, but I just find it easier to just reload it and restart it from here. It's a bit more brute force, if you will, but... And so now if I refresh the page, it says welcome Luca De Alfaro, because it has taken from the auth object the first name and last name and used them here.